Good morning. Welcome to the final day of the 2025 AIAA SciTech Forum. I hope you enjoyed this week as much as I have. It's been great to see all of you here. I'm Dan Hastings. I'm honored to serve as the president of AIAA. As Clay said when he opened this forum, it's clear that the aerospace industry is accelerating innovation, connection, and technical exchange. It's been the largest SciTech forum with more than 6,200 people gathered. The Guiding Coalition, Technical Program Committee, and AIAA staff planned the forums with all of you in mind. Our goal is to assemble expert speakers on important topics in our community, along with curating technical depth that you've come to expect from an AIAA event. Now we want to hear your feedback on how your experience at SciTech has been. Please take a moment to respond to the email survey you receive. Thank you. We will be reading what you say. We must end this week with some heartfelt thank yous. Please join me in expressing your gratitude to the many people and organizations who have planned the 2025 AIAA SciTech Forum and made it such a success. Thank you to all of our sponsors, including our executive sponsors, Lockheed Martin, GE Aerospace, Northrop Grumman, and RTX. And thank you to our incredible Guiding Coalition and Technical Program Committee, the hundreds of AIAA volunteer session chairs and organizers, and the impressive technical paper and session presenters. So let's say thank you. And finally, there are a few organizations and individuals that work behind the scenes to ensure that you have a safe, comfortable, and enjoyable experience at this forum. Please join me in thanking Lumens, our audiovisual provider, Arata Exposition Services, Maritz, our registration provider, Event Pilot, our event app provider, the staff of the Hyatt Regency Orlando, and of course, the AIAA staff. Thank you all. And now, mark your calendars for SciTech 2026 next January, right back here in Orlando. We're going to begin by announcing the awards for the best student papers that were presented during this week's forum. I'm going to ask Dr. Leslie Weitz, Chief of Technical Activities Division, to join me on stage to present these awards. Okay, the following student paper competition awards will be presented to the winners, where a single paper can only win one award. The first set of student paper competitions come from the Aerospace Design and Structures Group, the highest ranked composites-related paper based on manuscript and presentation quality recognized with the American Society for Composites Student Paper Award. The winner is Emmanuel Vielma, University of Texas at El Paso, with the winning paper, Low Velocity Impact Response of IM7 5321 unidirectional laminates, reinforced with vertical aligned carbon nanotubes. Congratulations. Next is the Harry H. and Lois G. Hilton Student Paper Awards in Structures. This award recognizes an outstanding graduate-level structures-related paper based on manuscript and presentation quality. It's part of the endowed student paper competition made possible by AIAA fellow Harry Hilton and his wife Lois. The winner is Aniruddha Gulapalli, Cardiff University, Wales, with the winning paper, A Model-Informed Approach to Robust Calibration of Experimental Guided Wave Modes with Cyber-Physical Systems. Next, the Lockheed Martin Student Paper Award in Structures recognizes an outstanding structures-related paper based on manuscript and presentation quality. The winner is Maruf Billah, Virginia Polytechnic University and State University, with the winning paper, Design of Functionally Graded Inconel 718 Alloy Structures by Developing Material Property Closures. Thank you to Lockheed Martin for your support here. The Jefferson Goblet Student Paper Award is the highest ranked aerospace design and structures paper based on manuscript and presentation quality. It was established over 20 years ago and named to honor Thomas Jefferson. The winner is Nico Peters, University of Calgary, Canada, with a winning paper, Modeling Thermomechanical Behavior of Additively Manufactured Quasi-Woven Shells. Our next Student Paper Competition Award is sponsored by the Fluid Dynamics Technical Committee. The Professor Gertie Carmen Gia Memorial Award to an international graduate student studying in the U.S. for an innovative approach to computational fluid dynamics that leads to a greater understanding of the flow physics for a problem related to aeronautics or astronautics. The winner of the 2025 AIAA Professor Gertie Carmen Gia Memorial Award is Badrul Hassan, University of Maryland, Baltimore County, with the winning paper, Comparison of Several Neural Network Enhanced Subgrid Scale Stress Models for Mesoscale Hurricane Boundary Layer Flow Simulation. Our next Student Paper Competition Award is sponsored by the AIAA Guidance, Navigation, and Control Technical Committee. The Guidance, Navigation, and Control Best Graduate Student Paper is based on several GNNC technical research topics. The winner is Sky McEwen, University of Washington, with the winning paper, Auto-Tune Primal Dual Successive Convexification for Hypersonic Reentry Guidance. Unfortunately, she's not able to attend. We'll send her a congratulations. Our next Student Paper Competition Award is sponsored by the AIAA Intelligent Systems Technical Committee. The winner of the Intelligent Systems Student Paper Competition is Marek Hamola, Massachusetts Institute of Technology, with the winning paper, Uncertainty-Driven Distributional Reinforcement Learning for Flight Control. Congratulations. Our next Student Paper Competition Award is sponsored by the Meshing Visualization and Computational Environments Technical Committee. The winner of the Meshing Visualization and Computational Environments Best Student Paper is Alexander Coppins, University of Michigan, with the winning paper, Aerodynamic Shape Optimization with Curved Mesh Adaptation. The next Student Paper Competition Award is sponsored by the AIAA Small Satellite Technical Committee. The winner of the 2025 Small Satellite Best Paper Award is Matthew Wernicken, Columbia University, with the winning paper, Icarus, Retractable Drag Sail for Small Satellites Use Shape Memory Alloys. Unfortunately, he's unable to attend. Send him our congratulations. Our next Student Paper Competition Award is sponsored by the AIAA Terrestrial Energy Systems Committee. The winner of our Best Student Paper Competition Award is Jerry Hamilton, University of Alabama, with the winning paper, Investigation on, need some water, Elastomer Interactions. Hang on. With multiple blends of synthetic paraffinic kerosene and aromatics.
Our next student paper competition award is sponsored by Uncrewed and Autonomous Systems Integration Outreach Committee. The winner of the 2025 Uncrewed and Autonomous Systems Best Paper Award is Lena Brugger, Technical University of Munich, Germany, with a winning paper, Dynamic Assessment and Control, Insect-Inspired MAV with a Perching Mechanism. And the honorable mention is Sonini Gupta, Kennesaw State University, with a winning paper, Design, Development, Modeling, and Progress of ALICE, Autonomous Lunar Investigation Communications Explorer. Congratulations to all of them. Now we're going to turn to our program. We'll conclude the forum by imagining the future of aerospace. The session this morning, specifically addressing the future of innovation, is moderated by Dr. Tony Mitchell, Chief Technology Officer, Electromagnetic Defensive Solutions, Honeywell. Tony has broad experience in the aerospace and defense industry, as well as government and academia. Most recently, he served as the Vice President for Advanced Technology, Business Development, and Strategy at CASE, where he led cutting-edge innovation technology development. He served as Vice President, Business Development Strategy for Dynetics, where he led a team responsible for growing the company's advanced research and development, advanced manufacturing, and rapid prototyping group business. Tony served for 20 years as a U.S. Air Force officer, with his last assignment as Executive Director for the Air Force Scientific Advisory Board. He has obtained a number of advanced degrees and holds numerous certifications, has published 60 papers, and was an associate professor at the U.S. Air Force Academy. He's the perfect person to lead this discussion. Tony, please come up with the panel speakers.
Good morning. I'll let the panelists come up and I'll Is the lapel going? Okay, I'll step away from the microphone then. Good morning, everybody. Thank you for being here on this Friday. Dr. Hastings, thank you for that introduction. I don't have a whole lot more to add. That was plenty, I'm sure, for most of you. But I'm really excited with this panel. We have folks from space, from aviation, from commercial, defense. I'll represent the big company if a question comes that way maybe, but mostly startup and innovative companies, which is very exciting. And we're going to hear from these industry disruptors, as I like to call them, as they share their insights and outlook on the technology that's the future and what innovation really means. I'm going to let each of them introduce themselves for a few minutes and tell you about the companies that they represent. And then I have a couple of questions to get us started, but you'll see a QR code up there and you can start to push your questions to the app. I'll be monitoring that and hopefully we'll get to some good questions and to most of the ones that you have. So with that, I will hand it off, and I think we're going to start with Steve. So,
thanks, Tony. So Steve Milano, I lead advanced effects for Anduril Industries. Quick overview of Anduril Industries. It's a defense tech firm that does software-defined, hardware-enabled defense tech innovations. I think 2 years ago, I probably could have summarized the portfolio of Anduril in about 30 seconds, but today it's hard to keep up with the pace. Publicly just disclosed that we acquired Numerica, so adding C2 and radar technologies kind of to the portfolio. But everything from subsea autonomous vehicles to space systems, as well as aerial autonomous vehicles, which is kind of my domain where I live, in one-way attack drones and those types of spaces.
Hi everyone, I'm Jeff Schloemer. I'm the Senior Director of Engineering for Astroscale U.S. If you haven't heard of Astroscale overall, we're actually a global aerospace company headquartered in Tokyo, Japan. We have offices in Tokyo, Harwell, UK, Toulouse, France, and then the US actually owns an entity in Israel, headquartered in Tel Aviv. The mission of Astroscale, if you haven't heard of it, is to create a serviceable space domain. So very simple concepts of how do we remove debris from orbit and also build serviceable spacecraft that also service other spacecraft. So if you're looking at the chart out here, you see the traditional 3 R's you learned in elementary school: reduce, reuse, recycle. We added 3 more to make it a little more graduate level, but really address holistically what a sustainable ecosystem in space looks like. And sustainable is an easy word to throw around, just like innovation, and I'm sure we'll get to that, Tony. But what we mean by sustainable here is the entire system works together to minimize net waste in the overall broad system. So basically learn to live off the land. In addition, we don't want to steal from the future. So we don't want to take away economic benefit from future generations of what their access to space looks like by utilizing resources that are ultimately theirs. As well as we don't want to steal from our neighbors. You don't want to steal from other people or industries or other groups. So what does that look like in practice to start? We have that reduce, reuse, recycle, but really end-of-life services for other spacecraft. How do we extend the life of spacecraft that are already up there, get more use out of them? Right now, a lot of spacecraft look a lot like these. They're single-use water bottles, single-use spacecraft. When you're done, you leave it where it is, and someone will go pick it up. That's not sustainable for the long term. That's stealing from the future. That resource is the orbit. That resource is what's already in space. So how do we empower generations to utilize space going forward by starting with addressing that concern now? In the US office, we're actually building 2 satellites right now, addressing some of these 6 R's that are on there. One of them is a life extension vehicle called Lexi P or Lexi Prime. In Japan, it's bad luck to use the number 1, so we're Lexi Prime. Lexi P is designed to go off and service a geostationary comm satellite. Much similar to the Northrop Grumman MEV, we offer some additional complementary services as well, providing inclination correction against those satellites, as well as east-west station keeping, and then can ultimately move that satellite to graveyard. The other satellite that we have is called the Astroscale Prototype Satellite for Refueling, or APSR, and that is a hydrazine shuttle providing hypergolic fuel transfer between a fuel depot that will also exist in GEO and then a client satellite. And then the advantage there is you have clients who can be refueled but ultimately don't have to bring the complicated technology of rendezvous and proximity operations, fancy word for getting close to another satellite, with them, and so they can still be refueled overall.
Thanks, Jeff.
Buddy Sessoms. I'm with Electra Aero. We're out of Manassas, Virginia. Basically, we want to create a new class of aircraft that can come into your backyard, essentially, much closer to where you work, live, and play. We want to create ultra-short, direct aviation, and we want to do it sustainably. We have an architecture with that can promote sustainable aviation when the technology is ready. What you see in the upper left-hand corner is how it all started. Traveling by air is pretty miserable. How can you easily get from New York to DC in a new way? We all saw the growth of the eVTOLs that were battery only, and we thought we could do better with a blown lift concept. And there's 3 technologies that made that possible: the blown lift wing, full span, hybrid electric propulsion, and fly-by-wire made it to where an average pilot could operate it safely. So we built the prototype that you see in the upper right-hand corner. We've been flying that regularly for about a year now, a little over a year, and we've proven the blown lift concept. The fact that it actually does work. We can depart and approach, just like a helicopter, into larger heliports. And we spent about the past year finalizing what the production configuration will be like. That's the EL9. And as you can see, it's quite a large aircraft, but it can still take off in 3 times its length. So you can drop a 300-foot barge anywhere, and we can take off and land from it and carry 9 passengers. About 1,100 miles is the max range for this aircraft. So unlike battery-only options, we have very high-value utility. One of the nice things, since we are a fixed-wing aircraft, is we use existing regulations, existing pilots. We don't need battery miracles, and we don't need expensive charging infrastructure. That's Electra.
Thank you, buddy. And thanks to all the panelists for that brief introduction. I hope that the audience has heard that, this interesting mix we have here of some commercial, some defense, and especially the innovation ideas that are coming. And so that's kind of where I want to start. You can see the QR code up in the corner, so questions can come through the app. I'll be sorting and watching them as they come, and hopefully we'll get to them. But my initial question for you guys as we sit up here is just about innovation. I'd like you to think about what that means to you. What does innovation mean? How would you define it? We use it all the time. It's thrown around. There's chief innovation officers. There's chief innovation units, right? So how would you define innovation, and what does it mean to each of your companies? Let's start there, and then we'll see where it goes. So go ahead.
Yeah, so I think at Anduril, there's a lack of a definition of innovation intentionally.
It's probably good, but
yes, yeah. It's defined one way. It is a new process, a new product, a new way of doing things, and that's all that it should be. And so I think by definition, just aggressively attacking problems creates innovation, and so you don't have a need to define what is it in your ecosystem. And so I think at our organization, at Anduril across the board, we tend to allow innovation to kind of be something different where it lives. And so you go to where it lives, it comes from the ground up, and you actually see it come out of the engineering core as opposed to a top-down innovation strategy, so to speak. And so I think that you end up getting the best ecosystem of that. So I think that the way that we define innovation is naturally solving hard problems and identifying the new ways, processes, and products that actually solve those hard problems.
Nice.
And I think to piggyback off of that, I mean, we don't have a standard definition of how engineers should innovate at Astroscale either. I think it comes from a wholesale vision of what we have. Like if you think about what a circular space economy looks like, it is an upending of everything that we have been doing for the last 50 to 60 years in space. That's the innovative concept we're trying to go for. That's the innovation that comes behind that. And so innovation in that front is it can't be obvious and simple. Like if it was that, we would have already gone there. And so what are the hurdles that are sort of in the way from the present architecture to that future vision architecture, and how do we get from that state to the other? My wife's a chemist, so I think about it in some ways of that potential energy curve of how do I get from one state to the other? I need that activation energy. So a lot of innovation comes from not only just what that future vision state looks like, but how to transition between. So many of you have probably worked in industries or on products that feel like they're the next big thing, and that transition is often the hard part. I don't want to say innovation is easy, but often it's easy to take technologies and look at them and say, hey, they're innovative. We see that has to be a wholesale architecture to include a business model, to include policy, which is why Astroscale brings along those as well from an innovation perspective. How do we sell space services? How do we regulate them as well? All of those have to come along for the ride. And then long-term innovation to us also has to be built upon. Like you have to set up an architecture that ultimately lasts longer than 5 to 10 years. Standards are sticky, architectures are sticky. In space, we're still doing things because the Romans chose a certain stickiness of how large their roads were. Not even kidding. So thinking through the implications of what those architectures look like, because they last a long time.
That's great, buddy.
So to build on that, we also feel that there's not a true definition. But one thing that Electra feels very strongly about is it has to create value. You've seen a lot of battery-only transportation or implementations of hybrid propulsion that don't really create a new capability. They're just different. They're new. What we do at Electra is we are actually creating a new value, a new way to travel. And we're doing it in a way where you can still carry a high utility a long distance. And that's what we see as innovation. It has to be commercially viable, and it has to create new capability.
That's a great point, because we are all in business, right? So we have to find a way to make it profitable, or at least help society out, right, if it's a nonprofit type of event. So that's great. I'm going to dovetail that one with the first question from the audience because it meshes with one of the ones that I had. So the question from the audience was, how do you distinguish between technology that is aspirational as opposed to realizable? And I guess I'll add my twist. So, right, is it aspirational, realizable? Are you looking for, or do you think from your companies, in a revolutionary innovation model where you're, upheaval and changing things drastically, or is it evolutionary where you're taking baby steps to get there? So maybe those two questions together: revolutionary versus evolutionary, and what did he say? What was the word? Aspirational versus realizable. Yeah. What are your thoughts?
I think that it's both in both cases, right? And I think earlier on, Anduril's kind of growing, exponentially at this rate, and so we have early aspirational type of innovative ideas, and then we have kind of more evolutionary based ideas as products mature. That's just kind of the natural flow of things. But I do think that in order to disrupt yourself, you need to really look at the sensitivities and look at I like the chemistry analogy that you use. It's like you need those catalysts. You need to find what are those catalysts that turn you from one state to the next, and understanding what those are. And so you can look at those aspirational technologies. You can look at those things that are potentially revolutionary, and identify succinctly what are the sensitivities necessary to pick and choose the things that are actually going to be successful, that then become the next generation's evolutionary or kind of realizable technologies. Because at some point, everything that you're doing today that is evolutionary or realizable technology or realizable market space that you're pushing an innovative product into, at some point was aspirational. And so there was some catalyst in the past that somebody identified to enable that to happen. And so what we essentially are looking for is those sensitivities and those aspirational and kind of revolutionary technologies to transfer them into that new state and bring them to kind of to that next level of maturity.
That's great, Jeff.
I think for us, there's a revolutionary end goal, as we talked about with the architecture. It has to come. It can't come with the expense of feeling alien to a customer. It's got to still feel approachable. If it doesn't work with what they already have, it's ultimately not transitionable for them. It doesn't work. It doesn't add the value that you brought up as well. So that economic side of, yes, you need to have the revolutionary aim, but it can't come at the cost of not being approachable in the moment. And I think with that aspirational technologies, we try as hard as possible to use what's already there. That allows a speed to market, that allows customers to buy those services now. And you can buy those services now. But we also know that there's technologies we're going to need to make it the next step and the next step and the next step. And what does that N+1 vision look like of that architecture? So setting into place things that reduce the risk for those follow-on aspirational technologies, but not necessarily taking all of them on with the singular mission. So a lot of the rendezvous and proximity operations we have are actually done by cameras that are very cheap and off the shelf. We're not trying to invent a new camera. We're trying to take what's already there, package that in a way that no one's seen before.
I completely agree with both my colleagues here. You can have both. You need to provide or build an architecture that can grow with you towards the greater vision. You have to have the large vision. For us, it's sustainability. We can be sustainable right now as a plug-in hybrid, and as the technologies improve, we can eventually go to battery only when it provides the utility that it needs. One of the things that attracted me to the company was our founder. One of his concepts is think big, start small, act now. And so evolution does become aspirational. It's all building blocks. Just make sure that you provide that path and act quickly and never stop.
Thanks. I appreciate those insights. I think it is a mix, right? That's where we all did, and we need to think outside the box. I've got a couple of questions I'm going to try to merge that come, but as I do that, I'm going to ask you one more that I had prepared. I want you to think about your innovation cycle. So I like what you just said, and I'm not going to get the 3 words right, buddy. So come back. Maybe I'll start with you. But what does that innovation cycle look like in your companies? Was it an idea first and then funding? Was it a combination of funding and a new idea, or was it an aha moment, lightning struck? Right. So if you could kind of think about where the companies that you guys represent started and How did that innovation cycle go? And maybe we'll start with you on this end.
Sure. So, again, we all likely had to fly to get here. It wasn't terribly pleasant. So the whole concept of having to go to a hub and spoke system airport, get there early, wait, we want to do away with that. We want to bring an aircraft into your neighborhood, essentially. And blown lift has been around for a very long time, but it really wasn't practical, nor was it safe, because it relied on the skill of the pilot. But now we have a system with hybrid propulsion, distributed electric propulsion, where we can have a fully effective blown wing. And when we add in fly-by-wire, we can make it easy for any pilot to fly. So that's what started this. But in terms of what the aha moment was, it was the fact that the technology exists today to where we don't have to do what the eVTOL battery-only companies were doing, and we can get very similar value. So again, it's think big, start small, act now.
So for Astroscale, Nobu, our founder, founded the company over a decade ago. Nobody was thinking about space debris or cared to the level we do today about space sustainability a decade ago. That took vision. That took a courage to go look at a problem and say, how do we address this so that we're not stealing space from future generations? And so the approach to how we do new solutions that we sell at Astroscale kind of follows that same paradigm and follows some of the, if you're familiar with kind of disruptive strategy from the late great Clay Christensen, that aspect of people are hiring you for a job to be done. Like sometimes your competition isn't what you expect, but ultimately you're trying to remove pain or give people enjoyment, and that is in essence what they're looking to go do. And our product cycle starts there of what are our customers' pain points, how do we delight them, and then once those happen, how do we then retain them and keep them buying in that cycle of space sustainability.
Yeah. Great. It's great to hear like kind of the approach that you both have and the approach that both of your organizations has, because it's refreshing in kind of the defense tech space. It's not always the case because free markets work. If there's a pile of money, people are going to develop solutions to try and solve that space. I don't feel like that's very innovative. Innovative is identifying an actual need, an actual gap in capability, which it sounds like both your organizations started off with that kind of idea first, then like pivot to funding. And so Anduril's no different. Our founder, Palmer Luckey, 7.5 years ago, started into defense tech, said, hey, the acquisition system for defense tech is broken. We think we can do this better. We can save hundreds of billions of dollars by making tens of billions of dollars for an organization, that type of thing. And being able to bring commercial technology to bear in the defense space. And so in doing that, you really start with the idea. And that ethos really carries through with all of our product design. It's like, there's nobody that's saying, you've got an internal investment budget of, X dollars, go find something good to do. It's bring me an idea and I will tell you what, we'll fund it to whatever degree necessary to make it a reality if it's actually a good idea, if it's an innovative idea, if it fills a gap, if it solves a problem that's actually out there for a warfighter in our case, like we're going to invest in it, we're going to figure out how to do it. So quite literally the idea comes first, the funding comes later, and we'll figure out how to actually make that happen.
That's great. There's a couple questions that are related to the comments you guys just made, so I'm going to combine them. One of them I think I'll synthesize. It says, just build it and they will come work. So maybe I'll just stop with that piece because it's kind of a multi-pronged, but what do you guys think? We'll start down at the other end of Steve.
So I think I mentioned it earlier. It's like understanding the sensitivities, build it and they will come does work if you understand the sensitivities of the environment that you're selling into, that you're creating solutions for. If you are developing solutions that are completely novel, that's great. But if nobody wants them and the ecosystem that you are trying to operate in has no need for them, then it doesn't solve any problems. So if you build something ahead of the need or faster, which is sorry for any service members in the room that are in the acquisition core. I know you were as well. Yeah, but it's not hard to outpace the defense acquisition system and innovate ahead of their capability. And so identifying what those needs are and delivering them ahead of that need, understanding those sensitivities can be relatively straightforward. And so operating on those cycles, I think, is kind of like, by definition, build it and they will come, but also you're getting some indication of what the sensitivities, what the environment is telling you that they need. And so you're solving a problem that has not quite been defined yet, and you're defining for yourself. So it's not really if you build it, they will come. It's building something that you've predicted will be necessary in the future. Cool.
Yeah, I would agree with that. And I think if you're ultimately building solutions to chase problems that don't exist, that's what's not going to be successful. But there is an aspect of you got to prove yourself when you're trying to be on the revolutionary side. There's a very healthy trust but verify aspect of that people want to see your stuff work. And so part of, if the build it they will come is really that proof test that says, look, this isn't just sci-fi, this isn't just paper, we're not just a company that makes cool designs but doesn't make them real or doesn't deliver on the promises we keep. The build it and they will come, if that's a trust building exercise, then that's useful because that's building relationship between you and your customers, and that's the intent of what it needs to be. If it is just putting cool tech out there for the sake of showcasing, that's probably not going to be as successful.
Yeah, the comment about customers is very important. So it would be highly risky to build it and they would come and just cross your fingers, obviously, right? So start small, simulate, subscale, but early and active engagement with your customers or your potential customers. That's the key. Electra has done that with both AFWorks and existing commercial operators. Talk to them early. Find out where their pain points are, because that's what's going to make them want your product.
Oh, that's great. One more question tied into funding, possibly. All three of you have founders who have invested, right, and have created these ideas based on theirs. Large defense contractors and commercial contractors then operate under a whole different system for funding. So the question here is, how do you, in addition to getting customers interested, how do you go about getting the customers excited to actually contribute to that process and getting funding to build it into a real market, right, to something viable? So.
Yeah. So it's multifaceted. So in our world, I think a little bit of the early onset of just like defining what you can actually do and bringing products to bear to prove that you can build that trust with the customer, so that there's some mutual respect and trust that you can actually deliver on the things that you say you can deliver. That's a little bit of the, if you build it, that they will come type of mindset. But as far as like generating like revenue streams, is that really the question? Like the investment?
Yeah, it's really how do you generate the revenue?
Yeah. In the defense world, it's a pretty cyclical and predictable approach, and so you kind of know where the funding streams are coming for specific capabilities, and you understand pretty discreetly where each of the services is going to spend their money. And so really, you need to perform, and you need to have a legacy of performance to be able to attract greater and greater returns on any investment, any innovation that you push into the market. One example that I'll use is with the Border Patrol and our counter-intrusion technology. So our tower systems that are kind of monitoring the border today. That was on our own dime. We had to go and actually demonstrate some of that activity ourselves before there was any acknowledgement that this technology works. It's supportable. It's something that we can do. And then you get into those cycles of being able to plan the requirements that then turn into acquisition structures and acquisition plans that can then get funded by the individual services. But it all starts with like building that trust up front. And those cycles aren't different across the board for every subsystem. It's building the trust, identifying the requirements and how you're solving the problem, and then the funding comes. And that's a very traditional like defense, U.S. defense funding system.
Yeah, ours isn't traditional. I mean, Nobu founded the company out of Singapore. We'll move that to Japan, and a lot of the venture aspects were backed out of. It was not a U.S. based defense contractor. It was an international space company, and trying to convince investors around the world that this was a good idea, that we should take the idea of space sustainability seriously. The first mission, we built a satellite on that money with venture capital money, and the rocket didn't bring it to the right orbit. And it was insured, and Nobu, the founder that he was, pushed all the chips on the table, and as opposed to building a repeat, upped it one more and said, we're going to build the next generation satellite anyway. And that took vision and courage, and ultimately that related to our ELSA-D mission, which provided demonstration of an electromagnetic docking system in space. And we learned things from that mission too, and that ultimately led to the success of the recent Address-J mission. If you like cool pictures of stuff from space, I highly recommend going to YouTube and seeing the actual pictures we've taken of a H-1B Japanese rocket body of Address-J. Like, that was a direct correlation of these failed missions up front, then the demonstration of ELSA-D. And now we have the ELSA line will continue within our UK and ultimately bring in the ability to now deorbit other satellites that have prepared docking tags on them. That took VC money to go prove all that out, and it had to do that with an industrial base in Japan that doesn't build the commoditization like we have here. We in the US can go off and put out RFIs and RFPs for buses and components. A lot of the Japanese office and the UK office even doesn't have that luxury. It doesn't have an aerospace industrial base to just buy things commercial. Astroscale is now public. June of last year, we were able to become listed on the Tokyo Stock Exchange. So that has changed now our avenue significantly of going from a VC funded to now a commercial company. And now we're really trying to focus on the revenue side, as shareholders now expect. We want to deliver shareholder value, which is a little different feeling than it was when we were VC back. So it's been a unique evolution of the company from the Astroscale side.
So like was mentioned before, it comes down to trust. You have to deliver on your plan. So make sure your plan is well thought out. Electra has been able to benefit from AFWERX. You'll also see that some large defense contractors have venture arms that can help out as well. But it really comes down to showing the value, the fact that you truly are creating value. And like in our case, we built the prototype, and then we went out and showed people why it's different, why it's not just an airplane, why we can approach and depart much like a large helicopter, and why that is different, why this is not just a cool airplane, but this is a new type of vehicle. So go out and demo your wares. You've got to show people what you have.
Yeah, so there is a build it piece that's important, right? That, hey, it's real. This isn't just a PowerPoint. This isn't just a cool idea, but it's tangible. It's something people could see, touch, taste, whatever, right? So we don't want to taste the rocket fuel, but yeah, I got it. There's some questions that are coming in that are specific to each company, so I'm going to try to combine them and then hit each of you to do that. I'm going to start with Electra. So this one pokes a little bit at the government too. So I'm just reading the questions. I'm not creating these, right? But with the transition of a new government coming in and some things, it says, so what's different in your concept versus some of the $100 million plus efforts that NASA has put out there to try to develop, or the government DOD, and you have some DOD funding, you have some other funding. So I guess the gist is, does NASA, does the government need to keep doing research and development, or should we let startups and small innovative companies take over that responsibility as we move forward? So I'll point it at Electra because it was more at the electric vehicles, but.
So, I don't know if the question points to this, but obviously the NASA Maxwell project, that effectively looks a lot like our prototype, right?
Sure.
Yeah. So we were able to realize what NASA was not able to fly. However, everybody wants to make the best use of their capital, right? Mm-hmm. So I do think that partnering with small companies like mine is how you do that. You do want to have entities like NASA, I know I've said AFWERX a lot, mm-hmm. but you want to have the governmental entities partner with the small companies because they're a much more efficient use of capital.
Yep.
I think the only thing that I would add to that is just like I do think that there's a position for research labs across the government, whether it's NASA, it's the service labs, those types of things. I do think that there's good research and development that happens in those labs. I've seen it. It transitions really well. But I think what they need to focus on is those sensitivities so that they can inform the free market so that we can go off and do these design of experiments that then turn into demonstrations and prototypes that can then be fielded. Because if the labs are having to do all of these types of development efforts on their own, they won't be focusing on actually like fielding capability that solves the problems that they were put in place to solve.
That makes sense. And I'm a long-term former DoD person, so I think a lot of ideas are generated in those labs, but they don't have the specific application or the revenue-generating stream in mind. And so commercial companies can come in, or you're right, startups can come in and use some of those ideas that are generated by government funding to then jump ahead and push towards an innovative topic. So since Steve jumped in, I'm going to go to Anduril. There are a couple of questions. One is about dual-use technologies. You guys do a lot more on defense than you do in commercial. But so are dual-use technologies an enabler for innovation, or does that constrain you to suboptimal designs depending on which path you're going down? And then the other one was, how do you combine the speed with which you're trying to work with the rigor that's required to demonstrate TRL, MRL, technology readiness level, manufacturing readiness levels, and the ability to actually produce at scale?
Yeah, I think commercial applications is an enabler for us. The dual-use mindset is something that we've kind of we've taken on as our core. So as we do product development, we think about dual use applications first and foremost. What this does for you is less on the innovation front from a technology insertion perspective, and more of just the innovation of the process of how you actually build, so engage with your supply chain and manufacture the things that you're building. If you haven't worked in the defense tech area, if you're building things, mill standards across your entire supply base can grind your process to a halt, and it can extend your timeframes for development significantly. It's no different in space and aerospace. So I think that it's a common thread, just like the governing bodies that define what those mill standards are. So having a commercial application allows us to go fast and prove out the capability first, which is good. But then going to the second part of the question, which is how do you get through all of those traditional milestones that are sometimes safety mechanisms, sometimes maturation mechanisms that show that you're hitting certain certification protocols to say that the system that you built, whether it's an air vehicle, submersible, or a satellite, that it can actually do the things in the environment that it says that it could do. I think that starting from the commercial space allows us to have a baseline of understanding of things that we can poke at in the traditional process. And so really process innovation, process maturation is something that we focus on a lot more than I focus on a lot more than like traditional product innovation, because the products are there, the engineers can build the things that are necessary to solve problems, but actually changing the government process for certifying something to fly in U.S. airspace in particular is challenging. And so working through those widgets to like break down the barriers to actually make that happen it's something that we have to go do, and it's something that we do fairly well.
Yeah, to keep your government funding, you have to meet those requirements, right? And there's cost, schedule, and all the other performance requirements that are there too. Can't all come from the investors. So that's great. Thank you. There's a couple of questions. Jeff, since you got the space hat on for us, here, you can represent all of the space.
Okay.
There's a couple good ones. So I'll read two or three of them together, and then you can figure out how you want to combine your answers. So the first one maybe is poking a bit, but is commercial space really commercial? So, right, or is there always the expectation if something goes wrong, the government is going to come and help bail it out? So that's one. Is it really commercial? And the other one is, what is the largest hurdle for commercial? Well, that's why maybe it is. So is it the capital side? Is it regulatory? Is it environmental sustainability? Yep. So I think they're kind of linked, and if you can try to help draw the connection, that'll get...
Yeah. The governments spend a lot of money in space. It's why we even got the dual use question overall, and dual use applies to the space fronts as well. And I don't think anyone looks at, like, the government spends a lot of money on logistics. No one looks at FedEx and UPS and goes, are they a commercial company? Yes, they are. Like the logistics overall in space and where the government spends its money does not inhibit a commercial model. I think it comes down to acquisitions, and what we've seen with the APSR, the refueler prototype that we're building in the U.S. is a really unique aspect of we see the government actively wrestling with themselves of what do they want to be the commercial line. Where does that line get drawn? Is that fuel? Is it Delta V? Is it a spacecraft? Like if I'm buying a service, what does that look like? And I think the hard part right now is the business models don't exist. That's why we're up here talking about innovation, is the innovation can't just be in the technological side. And so our goal from the beginning is we know we can't just sell to commercial companies in space. If you want to achieve the vision that we have, which is a sustainable circular space economy, everyone's got to participate in it. That includes militaries, that includes the U.S. military. And not selling to them because it's not commercial does not get you to your end vision. And the APSR system was designed to be compatible with both. We can refuel a government satellite that is equipped. We can sell them fuel. We can also sell ourselves fuel. We are also refuelable. The Lexi spacecraft is refuelable. And then we can sell commercial entities fuel. And it's not inhibited because one of them is government and one of them is not. And so it's really that dividing line I see as sort of an approach difference of we're not selling the government a box. We're not selling them a satellite. We're selling them a service. The service is refueling. That is just part of how the government will buy logistics, just as they buy logistics in all the other domains. We see that going into space as well.
I think that's a good answer. It's a lead into the next question I have too.
Awesome.
I like your idea of a service, right? Is it a product or is it a service? So the question that's here is what strategies do you take to ensure that your first time to flight, first time to delivery, first time to provide a service is as short as possible and as successful, because these are innovations that are risky, right? If we are truly doing revolutionary, not evolutionary development, there are risks involved. So how do you see your companies approaching that? And if you want to start, Steve, and we'll...
Yeah, I think the answer, the predicted answer is, well, you simulate a lot, you do a lot of modeling and simulation about what your predictive flight models are going to look like before you ever get into the air. And that's somewhat true, but I do think that you learn a lot from actually just flying hardware and like actually doing things and failing quickly and then iterating. We had this conversation, I think, collectively in the green room before walking over, but it's like failing is good, but the next step is more important, is failing and then recovering, learning, and then actually doing the next step and iterating that. And then taking all of that learning, folding it back into your modeling and simulation so you're better predicted for the next time, but it doesn't preclude you from having to actually fly physical hardware and actually do physical things in the future. So I think that like the fastest way to get to the final product is to accelerate, fly what you can as fast as you can, and then fail, learn, and then iterate that cycle as soon as you can. And it's going to be uncomfortable. You're never going to be ready for that first flight. And I'll let you say what you said in the green room, because I really like the quote, because about test-isms and...
Oh, yeah. The famous quote now. So that quote I was talking about is, if you're setting up a test and you already know that you're going to pass, from an engineering perspective, is the test worthwhile? Like, what are your testers doing? There's a certification side, and I want to make sure we acknowledge that side. But if you're going out there to learn and you're just doing it because you want to pass a test, I would encourage your testers to think beyond that. I think on the speed of innovation too is especially commercial and governments want solutions in space faster, and that makes it more challenging when you're also trying to do something that's on the innovative side, because you don't get an excuse. You're not like, well, can I have an extra year because we're doing something that's a little harder? And so our APSR is a 24-month contract. We got awarded, and we were expected to deliver 24 months later a spacecraft to the launch vehicle, our manifest ready. And we've had a few ECPs, but in general, we're keeping to that, and that's really hard to do when you're trying to meet the customer expectations for I need capability to space and be that innovative side of no one's building refueling spacecraft right now. There's not a lot of things out there that you can just rely on and borrow from to ultimately build it. So you're doing the innovation, you're having to do it at speed, and you're having to take those approaches that you mentioned.
Awesome.
Yeah, I mean, my product's a little bit different in that it's crewed. There's people on board. So we have a slightly different approach. As I mentioned, we have the prototype, right? So we got that together really quickly, got it flying so that we could learn from that. It's already been mentioned on simulation, sills and hills, copperbirds. Those sort of ground testing opportunities is where we'll be learning. Effectively, we need to approach our flight test as if it's a validation of what we already know on the ground. So very high fidelity, detailed ground testing is how we approach the speed of innovation. So that when we get to the actual flight test, where we as a company test first and then we have the FAA come on board and validate with us, is more validation than actual learning.
All right.
It's a good clarification. I can crash an autonomous air vehicle because there's no one in it. That's
Right.
Yeah, there's a lot of certification and flight safety things that come in when you put people on board, right? Yeah, that's definitely true. We're getting close to the end. I've got a couple of questions I want to hit, so we'll speed date here as we answer these. But this question was, there are a lot of non-credible, and this person says defense, but I'll say commercial ideas that come to fruition. So how do you make sure that those ideas are viable, and how do you sort the wheat from the chaff, right? How do you decide, okay, I'm not going to go that way, I'm going to go this way? And just big picture from your...
Again, it goes back to the sensitivities. So those sensitivities for the technology insertions, depending on where it's at in the spectrum, if it's a lower technology readiness, then the technology insertion is going to be, does it fill a gap in the future? What is the maturity? Is there a risk-reduced path to actually seeing this capability come to fruition? If it's more mature, those sensitivities become market dynamics, funding sources, customer requirements, time horizons, your staffing ability to actually ingest that capability and execute on it. Because if you have a great idea and you don't have the people to perform on it, then you've got a problem. You can't perform on it. So it's really a sensitivity analysis around which one how you pivot technologies and innovative concepts left or right.
Yeah, you got to prioritize, right? Yeah, go ahead, Jeff.
Know your customer. Your customer is rarely sensitive to specific technologies. You didn't buy a phone because it has $100,000 more transistors in it. You bought it because the engagement and what you want to go do out of it. So know your customer, know what they want, and know how your technologies apply to meeting that need.
Yeah, I like it.
You're applying technologies in new ways. Don't forget the first principles. No amount of money is going to overcome something that won't work. We're starting to see that, the bleeding edge of that in the eVTOL market now. Pay attention to the first principles. That's the key.
I like it. That's great. Thanks. We're going to end on a question about people. So that gives you guys a chance to give a little pitch as to why they should come work for you if they're looking for a job. So a couple of these questions were, do your organization see all employees as innovators or not, or are there restrictions? And then I'll say, how easy is it for you guys to hire? And how can you attract the attention? And then on maybe the corollary for those in the room who work for large defense contractors or large commercial contractors, how can they make that easier to attract young talent too? So combination.
So I'd say that it's relatively easy for us to attract people at Anduril, and I think it's because everyone's an innovator. Everyone has the ability to perform at the highest level in their function, and so we tend to attract people that want to go after hard problems. So maybe this is an anti-recruiting statement to say, like, if you're not interested in solving hard problems, if you're not interested in doing hard things, then Anduril probably isn't the place for you. It's a natural selection type of thing. Yeah. Maybe that's true across.
Probably true for all three. Yeah. See head nods. Yeah.
So there is a high level of innovation, a high level of autonomy that we place on people, and that can be stressful. It can be stressful to think that you own that path, that you own the development of an innovative process that you then need to go and execute. But it's worthwhile. It's how you instill a sense of meaning in people, and I think that creates an environment that allows people to want to come work at places like
That's
Anduril.
exciting.
Yeah, we're very flat as well. There's no monopoly on ideas or innovation within Astroscale overall. You don't have to have a senior in your title to be innovative, and that's not even you have to be an engineer in your title to be innovative. We get ideas from around the board, and again, we're trying to be innovative in not just the technological domain. So that requires us to have innovative marketing and innovative business development. And so I think to piggyback and extend what was already said, really there's a mission care about. A lot of people care about sustainability, and I come from a bit of a sports background, but we want people also with the discipline, because sometimes mission punches you in the face, and you got to be able to get back up. And it's easy when it's easy, but when it's hard, you got to still want to be there. And we want people who not just want to tackle the problems, but are willing to go through a few failure cycles in order to get there.
So I echo the same sentiments. We want people to innovate throughout the organization, very flat. Awards of patents happen for everybody, so the innovation is alive throughout. We do also have a very hard problem, but in my opinion, hard is fun. It's a nice type 2 fun. Might not feel like it at the moment, but you're really gonna love it on the tail end.
That's awesome. I think engineers love to solve hard problems, and we posed a lot of them here with this team. I'd like to take a second just to thank our esteemed panelists, Steve, Jeff, and Buddy. Thank you for being here this morning and for the great discussion, your thoughts from your companies. On behalf of AIAA, I have some coins I'm going to present to you. I'll do that in just a second. And I want to thank the audience for your questions. I didn't get to all of them, but I think I summarized a bunch of them. So thank you for your excellent questions and your participation. The closing Forum 360 session today is at 10 o'clock in the Regency Ballroom Q around the corner. And it's called The Essential Building Blocks Needed for a Thriving Commercial Space Sector. So there are still some space questions that I didn't get to. You can always come bug the panelists up here too. We'll stick around for a few minutes. But thank you again. Let's have a great day at the rest of SciTech.